Landboards presents Differential Scope Probe Card Part 5 New Board Layout Rev X2. After all the messing around with the differential probe card, the first version X1, we did new board layout, and here's the X2 version of the board. We bought it from Osh Park to get it in quicker. It definitely cleans up the analog stuff, and we're going to take some time here to take a look at it and see how it did. We went ahead and set the board on standoffs, 440 size standoffs, to keep the pins on the bottom, the LED and the switch, protected. We used the same banana cables coming in that we used in the other card, as well as the 2.5mm power connector, which we connected up to a 9-volt wall wart again, as in the same setup as before. We took a bunch of measurements with a scope, and here's the captures of those measurements. They show quite a bit of improvement over the previous layout. In fact, we didn't really see any serious issues with this layout. The first capture here is at 1 megahertz. The top signal is the input signal, and the bottom signal is out of the differential probe card. You see a little bit of fuzzy on the output. It's really not too bad. Same sort of ringing on the output that you can see on the input as well. So all in all, a pretty nice signal. Here's a capture of a sine wave. It also looks pretty clean. Maybe a little bit extra fuzz on it, but not too bad. Here we've dropped the signal generator frequency down to 1 kilohertz, and you can see the AC coupling drooping from the input and output stages of the probe part. Here's the signals at 10 kilohertz, much less time for drooping to happen in, but still noticeable. Here's a signal at 100 kilohertz, certainly very, very usable at this frequency and up. And here's the original 1 megahertz signal again. We'll take a look next at the rising and falling edges. The performance of the rising edge is certainly acceptable here. It looks like it's a little bit quicker than the input signal. Also, there's a little bit of ringing, but we don't have the gimmick cap installed on this circuit. All in all, it looks like this would be a perfectly fine circuit to use. The performance of the falling edge is similarly nicely done, with nice clean edges and not too much ringing. Here's a bare card with the new layout. It has quite a few changes from the previous layout. We'll try to go through and point out some of the differences between the two layouts and maybe take a look and see how that helped. We beefed up the capacitance and the output of the regulator because we noticed there was issues with ringing in the previous edition. This one increases to 2 locations C8 and C10 of 10 microfarad capacitors. We shortened the etch length from the input connector there, as you can see at top with C1, to be quite a bit shorter into the capacitor, and out of the capacitor into the resistor also was made to be quite a bit shorter. That solves some of the issues we were seeing last time. We put ground rings around the places where the feedback resistor and the input resistor meet, and the other things in that circuit as well, and then spiked it to ground all the way around that part of the circuit. Also, the input stage is completely free of ground and power planes. Here's an example of some of the black magic that was recommended by the datasheet. This is the ground. If you look in the middle of R6, there is an etch running through there that has no solder mask above it, and that's connected up to ground, and it supposedly cuts down on the capacitive coupling of that resistor. Apparently that all works because this circuit is working spectacularly well. Neat. So what's next? Well, there's certainly quite a bit more characterization that we want to do here of the circuit to get a feel for how well it works, find out what the limitations of it are, and maybe play with the scaling again. But we did want to get this video out because we know that some people out there were waiting with bated breath to find out what happened and if we got it working. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of these cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.